again. This is Miss Toy. Welcome to video 4.3, Graphing Rational Functions, Part 3. We're going to look at one more example of one of the more complicated rational functions that has more than one vertical asymptote. Again, we're going to go at it the same way, find asymptotes, intercepts, points of discontinuity, and then look at properties, domain and range, increasing and decreasing intervals, and behavior. Let's get started right away. When can a graph cross an asymptote? Believe it or not, this happens. Even though in the past you've been told an asymptote is a line that a graph approaches but never reaches or touches or crosses. Well, that's kind of a simplistic way of looking at it, and we're going to find out that there are some cases where a graph can cross an asymptote. So let's take a look at what we've got, and we can discuss that more a little bit later. Our function here is f of x equals 3x over x squared plus 2x minus 8. Now remember, our first step is always to try to simplify our function. Notice that the top does not simplify or factor, but the bottom does. We can simplify this into x plus 4 and x minus 2. Again, nothing cancels here, so we are going to say that there's no point discontinuity. Now let's look at our infinite discontinuities, our asymptotes. To find our vertical asymptotes, we're going to set our denominator equal to 0. Since it's already been factored, we're going to set each factor equal to 0. So x plus 4 equals 0. Subtract 4 from each side, and x equals negative 4. And x minus 2 equals 0. Add 2 to each side, and x equals 2. Let's plot our asymptotes, or let's draw in our asymptotes at negative 4 and at positive 2. Okay, now our horizontal asymptote. Look back at the original function, which we haven't changed. We just simplified it. We just factored it. Notice that this function is bottom heavy. Okay, we have an x to the first on the top, and we have an x to the second on the bottom. So n is 1, that's the power of the numerator. D is 2, that's the power of the denominator. That's a bottom-heavy function. In that case, remember, our horizontal asymptote will be y equals 0. Now, of course, if this had a k value, then that would shift the function up and down, and our horizontal asymptote would shift also, and we would get y equals k. But in this case, we do not have a k here, and therefore our asymptote is just y equals 0. Let's put that on our function right away, or let's put that on our graph right away also. Okay, moving toward our intercepts, remember our x-intercept occurs where y is 0, and our y-intercept occurs where x is 0. To find our x-intercept, as long as there is no k term, all we have to do is set our numerator equal to 0. If we set 3x equals 0 and divide both sides by 3, we get x equals 0. Okay, let's plug that in, and we have an x-intercept at 0, 0. Notice that if we put this point on our graph, that if we have an x-intercept at the origin, we also have a y-intercept at the origin. But let's just go through the paces. To find our y-intercept, we plug in 0 every place where we have x. Looking at the original function, that gives us 0 on top, 0 on the bottom, except for that negative 8, but 0 over anything is just 0. So we're going to have our same intercept, or the y-intercept at the same place as the x at the origin. Well, we know that in order to graph, we have to have at least 2 points on each side of each vertical asymptote. We only have one, so we're going to need to do a little bit of work here. Let's look at our data table, and let's stay in the middle here. Notice that our point, our x-intercept and y-intercept, is actually right on our horizontal asymptote. We're going to talk about that at the very end, but just so you know, it is okay. Now, I want to find points on either side of that point because I want to know what's going on here. I want to know what that middle portion looks like. So I'm going to try -1 and +1. Plug -1 into the numerator and we'll get -3 on top. Plug -1 into the denominator, -1 squared is 1, -2 is -1, -8 is -9, which simplifies to 1/3. At -1, we are at +1/3. Let's try +1. Plug it in. 3 times 1 is 3. 1 squared is 1. Plus 2 is 3. Minus 8 is -5. We have -3/5. At +1, we're at -3/5. Well, now we have enough information here to draw in our middle portion of our graph. Remember, it has to hug the asymptote. So we're going to draw this. We're going to connect those points and go towards our asymptotes. Interesting. Right, well, we know we're going to have two more pieces. We know we're going to have something to the right of that asymptote at x equals 2 and something to the left of that asymptote equals -4. So let's plug in some values. On the right, let's use 3 and 4, and let's see what happens. 3 times 3 is 9. 3 squared is 9, plus 6 is 15, minus 8 is 7. So at 3, we are at 9/7, just a little bit more than 9. Plug in 4. 3 times 4 is 12. 4 squared is 16, plus 8 minus 8 leaves us with 16. Let's simplify this one, and we get 3/4. So at 4, we're at 3/4. Again, now that we have 2 points, we have enough information here to draw in our branch. And it's going to go through our 2 points and towards our asymptotes. Remember, it does not touch, it does not cross. Okay, let's find our branch on the left-hand side. We're going to use values less than -4, say -5 and -6. Plug those in. -5 gives us -15 on top. 25 minus 10 is 15. Minus 8 is 7. -15 sevenths. So at -5, we're at -15 sevenths, which is a little less than -2. When we plug in -6, we get -18 over 36 minus 12 is 24, minus 8 is 16, -18/16, or -9/8, just a little bit less than 1. And again, we have enough information now to draw in this branch. It's going to go through our 2 points and approach our asymptotes. And there's our graph. So when can a graph cross an asymptote? Well, I think what we need to do is we need to go look at the definition of an asymptote again and make sure that we aren't breaking that definition. So here's our graph. I'm going to read the definition of the horizontal asymptote. It says a horizontal asymptote is the line y equals b for a function f of x if, as when f of x approaches b, as x approaches infinity, or x approaches negative infinity. Have we defied this definition? No, it is true that our asymptote is an asymptote in the extremes. The graph approaches b as x approaches infinity, that's all the way to the right. Our graph also approaches b all the way to the left, or as x approaches negative infinity. It doesn't say anywhere that the graph has to approach the asymptote or not cross it in the middle. So remember, horizontal asymptotes can be touched or crossed in the middle, and still our definition applies. Let's go ahead now and look at domain, range, and behavior, and increasing and decreasing intervals. We'll start with domain. Remember, domain is how far left and how far right. So, looking at our graph, it starts forever to the left, which is negative infinity. It goes all the way to the right till it runs into the first vertical asymptote at negative 4. It does not touch the asymptote, picks up on the other side of the asymptote at negative 4, goes all the way to the asymptote at 2, doesn't touch it, picks up now on the other side at 2, and goes all the way to positive infinity on the right. Our range, notice, and when we talk about range, we talk about how far down to how far up, goes all the way to negative infinity, and if we just look at that middle section, we can see that it covers every single y value, there are no gaps, and goes all the way to infinity. Now, end behavior. So what is this thing doing? As it goes all the way to the right, we'll look at right end behavior. As x approaches infinity, f of x approaches the asymptote at 0. If you look all the way to the left end behavior, as x approaches negative infinity, the graph is doing the same thing. It is approaching the asymptote at 0. Last but not least, what is our pre-cal pest doing when it travels from left to right? Is he increasing or is he decreasing? And is it over the whole domain? Notice, he is decreasing from left to right. He's going downhill, downhill, and downhill. He seems to be decreasing over the whole domain. All right, this concludes part 3 of our video, our second example. I hope everything is clear, and we can answer any of your questions when we see you on Monday. Hope you have a great weekend.